This is Gary Marr from Glendale Community College. This screen capture is for my CIS 150 AB students. And in this screen capture, I'm going to talk about some of the topics covered in Section 3 of the textbook. Section 3, for the most part, is about programming structure or structured programming. And there's three structures that we cover in that chapter. One is a sequence structure, which we've already had some experience with both in pseudocode and flowcharts. And that's essentially just an assignment or calculation statement. So something like what you see on line 12 here in front of us is a sequence statement, sequence structure, excuse me. That would be reflected in a flowchart as a rectangle, and it also could be something like a calculation, which we see down here. But it's not going to have any kind of decision involved or any kind of looping involved with that kind of structure. It's the very simplest structure we have. The other two structures are more complicated. One is an if structure or a decision structure. And then there's a looping structure, which we'll show with a do-while loop. I've got two examples I'm going to go over today. One is the if statement, and the other is the while loop. So this particular example is for discount processing. If you order a certain number of books, you receive a discount from the store. So if I go through this line by line, you'll find that I'm using some comment symbols here from Python. There's my start, which indicates the beginning of my pseudocode, another comment showing the declarations. You can optionally, it's probably a good idea at this point in time, since we have talked about data types, to identify the data types, whether it's a variable, whether it's a constant. This has no constant in it. Essentially, because everything is a lowercase, could it have a constant? Yes, there could be a magic bullet solution for discount, for example. I believe book amount, total, and cost would probably all have to be variables. I'm initializing a couple of these as float, and then one of them is an integer with a value of 10. If it was a text value, it would say text instead of number. And again, I don't care what goes in there as long as you're consistent. You could put float in there. You could put text, character, string for the letters that you'd use in this application or this particular logic. Just be consistent throughout your pseudocode. This is going to look a little bit like some Python here in parts, because one of the things I always do is I try to make these little samples available in Python so you guys can at least run them and check them out. I won't do it in this case, but I will tell you that the books variable, which wasn't initialized up here, but will be initialized with this input, is going to capture the number of books from the user or from the store clerk, whoever is using this program, that would drive the discount process. Once that books variable is populated, it moves on to the next section of the program, which is the processing section. It has a compound if statement, a Boolean expression next to the if, which indicates if it's the logic necessary to determine if it's true or false. Now I've labeled both branches here. If I put a 5 in for books, 5 would be greater than 3, so then I would get a 4% discount. If I put 2 in there, okay, this would fail, it would be false. It would take the else branch, and I would get a 1% discount. Now, it's important to keep in mind that the else branch is optional. Okay, the true branch has to be there with an if statement, but the else branch is optional. The other thing to keep in mind too is that you also can nest these structures so that it's possible to have off of the first Boolean expression, instead of discount equals 0.04%, a second if statement. You'll see some of these illustrated in the book and some of the samples I've left in Canvas. From here, I'm going to calculate a discount. I'm going to calculate a total, and then I'm going to display everything to the screen so that the customer can see what I've done. There's a second example below here. This one does use magic bullet or constant values, and that is indicated by the uppercase. Same basic logic, except that what I'm doing here is instead of plugging numbers like 0.4 and 0.1, I'm plugging my 0.1, 0.4 up here, 0.04 up here on these constants, and using the constants as part of the calculation. The nice thing about using this is it's using magic numbers, which means that if I were going to go back to this application later on, and let's say my discount changed, I would simply just have to change the constants, and that would be reflected in the calculation down here. If I hard code numbers in there, that might be fine too if it's a simple program like this. But if I'm using that discount value in several locations inside my logic, I might miss one. And copy and paste is not a very reliable way to update code. This is a much more efficient way. I'm updating it in one spot, and all my existing logic should work just fine. That's my example of the if statement, or the decision structure. And what I've also done here is I've also put an example of a looping structure. Now, this one also has two parts. The first part has no looping, but it does a simple calculation of average calculation of test scores. It has 5 students, which it's going to ask for their score. It's going to take that score and add it to a total score, which is accumulating as the statements are processed. So for the first time, if the student score was 70, 70 plus 0 is 70. And the next one, if it's 75, it would be 75 plus 75, or 145, until it gets all 5 students. Then it'll divide that total amount by 5 to give me an average, and I'll display the average. Excuse me. This works fine if I have a class of 5 students, but seldom do I have a class of exactly 5 students. So what I've done here is I've come down and I've implemented a second pseudocode logic block that is going to use a loop, or a repetition structure. The declarations are pretty much the same. I've added 2 new ones, one called students and one called count. In the logic, the very first thing it's going to ask for is the number of students in the class. The nice thing about this is that I could have, for this particular logic, 1 student, 10 students, or 10,000. Whatever number I put in students, that will actually control the number of times this will loop through and accumulate that student's score for a test average. So rather than having this big, long program with just 5 students, I now have one that's much shorter, more complicated, but can accommodate any number of students. And I can use this for any class I teach, whereas this one up here can only be used for a class that has 5 students. Fairly limiting. So, to follow logic here, while is a pre-test loop, which means that if this is true, it enters the loop. If it's false, it skips it. Okay. This is pseudocode, so it'll look a little bit different in Python, or C++, C++, C#, JavaScript, etc. But for pseudocode, it's fine. The Boolean expression is here. Now, Boolean expression, just like with the if statement, will evaluate true or false. So if count starts at 1, and I have, let's say, 10 students, 1 is less than or equal to 10, so it enters the loop. And what it does, the loop, is essentially the same thing it did before. It asks for the score. It accumulates the score in the total score variable. It also displays some more information. I could have done this in my example above, but I just put it here. The nice thing is that when you're looping, the statement only shows up once in your code, but it loops through as many students as you're trying to average. So you can take a program and really kind of condense the number of lines in it. The next statement's important. The next one says, take my current value of count and add 1 to it. Now, that means next time around, count is 2. Is 2 less than 10? It is, so it goes through and asks the question again. If I fail to do this count action, then count will always stay 1. And what I've done with that is create a very expensive desk fan, because it's an endless or infinite loop and it will not end. I have to actually do a control break in the middle of the program to stop it from running, because this will always be true. I want to set up a situation here with a count variable, a scenario where eventually it becomes false. It'll exit the loop, then calculate the average score, and then display the average score to my user. So there's 2 examples of programs which are in section 3, the section on structures. If you have any questions, let me know.